The strategy of dividing a number by itself can be pretty tricky for a lot of students, particularly when we only ask it to them as an abstract expression of 4 divided by 4. We want to make sure we're using a context to help them to think through that situation when they don't quite know what that answer is going to be and they can't retrieve that from memory yet. So what I'm showing you here is this strategy of dividing a number by itself. I'm using the model of colored tiles. Those are the tools that I'm choosing to use, as well as some pictorial models, and then the abstract would be the numbers as well. So here's a situation that is this partitive division where I know how many groups, but I don't know how much is in each group if they're equally fair shared. So Jen has 4 stickers and she wants to share them equally with 3 of her friends. How many stickers could each of them get? So I might have concretely, on a board or something, just the picture of these 4 friends. And I would be having these concrete objects where I can say, well, I'm going to be dividing 4 by 4. So I have 4. I'm going to grab 4, but I'm going to be sharing it among the 4 groups equally. So I'm doing that kind of almost a one-to-one matchup here in this situation, right? And then the question is, well, then how many was the fair share? And so I can even just circle that the fair share, 1 person received 1. So 4 divided by the 4 ends up being the 1. Now, pictorially, what I can be doing is thinking about those 4 stickers, and maybe I put an X for 1 for each person. So each person gets 1 sticker. And the question is, well, then what was the fair share? Well, each one gets 1. I had my total of 4 stickers. And then each person was only able to get 1. As we move here to more of a tape diagram model, as we are kind of showing this connection here, remember always these representations are connected together. I have a total of 4, and I have 4 friends that I'm sharing. So I can give 1 to each friend, and that makes a total of 4. So what was the fair share? How much did each friend get? They got 1. And then I'll be recording that abstractly, that I have my 4, and I have divided it among 4 groups. How many ended up being in each group? It was 1 in each of those groups. The strategy is still the same. We're dividing a number by itself, and also the same model of the colored tiles, but I've changed the context now to be a quotative division situation where I know the size of the group. I don't know how many groups it's going to be. So Denise had a garden that could fit 3 tomato plants in each row. If she had 3 tomato plants, how many full rows can she plant? Well, I can grab the 3. So I'm taking these 3 and I'm dividing it by 3. Now, because the context is 3 of them go in a row, I might take those 3 and literally think about making 1 group. I'm not thinking about fair sharing this time because that's not the context. I take 3 and I make a row. And so then I know I only end up having 1 row. Pictorially, students would begin maybe making X's again for those individual objects. So row 1 would have a plant 1, a plant 2, a plant 3. That's all that there are. It makes 1 full row. That might also graduate in this tape diagram model of being able just to put the digit 3 to represent those 3 plants, and there's 1 row. Abstractly, remember, we also want to make sure students understand with equality that the equal sign is a relational symbol. So I might put the 1 first and say that 1 is the same as 3 divided by 3. As students are then exploring all various numbers with this number divided by itself, they'll see the pattern that it always ends up being a 1. But remember, we don't want students to memorize that like an abstract rule they have to remember. We want to build it through the context where they learn, oh, it's just going to be 1 of those. And then they're free, if it's an abstract expression, then to think about a context that makes sense for them to think their way through it.